Well, hello everyone, and thank you for joining us today. My name is Greg Root, and I'm the Director of Sales Enablement at Astadia, and I'll be your host for the next hour. Today, we'll be talking to our partner Micro Focus about 7 reasons to move COBOL to the cloud in 2017. We'll spend just a few minutes introducing our speakers and then discuss why moving COBOL to the cloud makes so much sense. We'll talk about your modernization options and discuss some of the key steps you have to take to make the move successfully. From there, we'll get into the process of moving COBOL to the cloud. We'll show you a couple of reference architectures and provide some self-assessment questions at the end. We'll close with a Q&A session. And as questions come to mind, please send them to me using the chat function in the GoToWebinar interface on the right-hand side of your screen. We'll stay here as long as we need to make sure that every question gets answered. Our first speaker today is Craig Marble. He's the Solutions Director at Astadia. Craig has more than 25 years of IT experience, including 16 years at Micro Focus. Most of Craig's career has been focused on modernization projects, but he's also worked in project management, pre-sales, and delivery management. Our second speaker is Ed Airy, Director of Solutions Marketing at Micro Focus. Ed has been working in the tech sector for about 17 years with a primary focus on application access, integration, and modernization. He has also worked in product management as well as pre-sales and service delivery. A little bit about Astadia. We are the technology consultancy where enterprise meets cloud. We've been in business more than 25 years, and today our focus is on helping customers and companies that are making the journey to the cloud. Our portfolio delivers an end-to-end solution that includes cloud strategy and readiness assessments, cloud integration, and management of both on-premises and cloud environments. We also have a large team focused on the unique challenges of migrating legacy systems to the cloud, and of course that's who we'll be hearing from today. Micro Focus has been a partner of ours for more than 2 decades. Micro Focus is a global enterprise software company that helps customers innovate faster with lower risk. Their software helps customers build, operate, and secure IT systems that bring together existing business logic and applications with emerging technologies to meet the increasingly complex business demands. So with that as the introduction, Craig, I will ask you to take over.
Great. Thanks very much, Greg, and thanks to everybody who's joining us. Today we are going to move now into kind of the preamble of the heart of the presentation, and we're going to start out right with the 7 reasons to move to the cloud. And initially this slide started out as the drivers, and then we realized that the drivers are really the reason to move COBOL to the cloud in 2017. So if we start on the left-hand side, you'll see that there are some traditional drivers that are not unique to really moving to the cloud, but are really a part of any modernization project. So anytime you look at modernizing, you have some traditional things that drive you to that. One, of course, being lower cost. So a lot of drivers for moving from a legacy platform to a newer platform at the cost of the older platform. It gets more expensive as time goes on because you have fewer vendors supplying the products and services and hardware that you need. There's also risk associated with legacy platforms, and we always try to reduce risk as much as possible in our businesses. And so if you're looking at maybe you're sitting on a burning platform, maybe a piece of hardware like a Unisys mainframe that are very expensive to replace, not so easy to maintain, or some other type of distributed hardware that itself is a burning platform, that can be a real risk for your business. So moving that to a newer platform and modernizing it certainly is a very good reason to move to the cloud. And then, of course, focusing on your business instead of your plumbing, basically, and that is if you're spending all of your time maintaining legacy environments, and not even just the applications, but the environments themselves that are eating up a lot of your resources, a lot of your dollars, by modernizing, you can then redirect those dollars to new ideas, new products, new services, and actually focus on your business and not on your infrastructure. So when we thought about putting this together, there are some new drivers, new reasons to move to the cloud that really came to light because of the cloud. And one of those is how you book or cost your investment in your infrastructure. So for example, in the past you would buy a mainframe or some other expensive piece of equipment and then depreciate that over a certain period of time. Whereas in a cloud environment, you can just include the cost of running your applications in the cloud as part of your operating expense, right? You get a bill from your cloud provider, whether that's Azure or Amazon Web Services or Oracle or whoever it is. They send you a bill and say, okay, here's how much you owe us this month. And so you have a way to account for that in an easier way than trying to do it over time. Another great reason is elasticity, and what I mean by that is if you think back, let's just take a scenario, and I'm going to pick a number out of the air. Let's just say that you have a mainframe and you need 2,000 MIPS to run your daily business, and that includes your development, your testing, and your production workload and everything. But there are those days within the year or the month or the quarter where you need maybe 2,500, maybe 2,700 MIPS. Maybe there's a certain day of the year that your customers do all of their ordering of all their activity, and that requires you to have a larger capacity. Well, that requires you to buy hardware that will handle that capacity in order to meet your service level agreement. So by moving that into the cloud, you only pay for what you use. So you don't have to make a large upfront investment for capacity and processing requirements that may only be, a handful of days out of the year or a couple days each month. So the cloud really helps solve that problem, and it's a great reason to consider moving to the cloud. Another good one is disaster recovery and failover security. So, a lot of large companies especially have disaster recovery plans that include separate data centers. So you have a data center in one city that does all your daily processing, and then you have a mirror center somewhere else in a separate geographic location. So that if something happens to one data center, you can go fail over to another. Well, imagine the amount that you could save if you didn't have to maintain that extra facility, right? If all of that was handled by your cloud vendor, and your cloud vendor took care of all of the mirroring sites, that provides a lot of value for a much lower expense. And then, of course, all of this, if you take all of this worry, all of this burden off of you, then you have the ability to get your folks to innovate for you. So provide services that give you an edge over your competition, whether that is providing services through mobile devices or some other mechanism that's yet to surface. It is an opportunity to focus on your innovation versus, again, the infrastructure or the plumbing. So I'm going to move in now to some of the modernization approaches or options. So you'll see a lot of these are, well, really all of these are the usual suspects, right? So it wasn't too long ago we heard people saying, well, I'm going to rewrite everything. That's just what I need to do. I need to get off all of this legacy, all these legacy languages, and just start over from scratch. And it sounds great, and in a perfect world it would be great, but the fact of the matter is it is very costly to do that, because there are a lot of pieces, a lot of things that need to happen. One is you need to do a study on your application that may be 20, 30 years old, a lot of business rules embedded in that application, most of them documented, some of them not documented. It really depends on your particular environment. So a requirement study needs to happen. Then you need to develop the specifications for the new application. Then you have the actual development and testing project itself, and a lot of risk involved with that. In fact, so risky that Gartner estimates that 60% of rewrites fail. So this is a risky proposition. Not only that, but there really is a limited return on investment. So, I mean, if you think about it, let's just say the project goes really well. Everything runs perfectly. You spend a lot of money, but you get an application that's all written in a brand new language of the day that is functionally equivalent. You spent a lot of money to essentially give you the same exact application you have today that will be considered legacy in a very short time. So there's really not a lot of value there. The next obvious option is replacing with a package, right? Which again, sounds great, except there are issues with that. One is there is a cost associated with that and also a risk in implementing those packages because there is always a functional gap. So your applications that you've developed over time are unique to you and your business. And when you buy a package that's off the shelf, it has some basic functions that everybody shares, but the things that are unique to you need to be redeveloped or they need to be plugged in somehow, and that in itself can be a costly proposition. So that isn't always the best option. Our preferred option and our recommended option is always reuse as much as you can. It is far less costly, much less risk because you've got proven functionality, proven applications, and you just move them to a new platform and modernize them. And it's just a way to leverage the investments that you have in your systems today. And it also presents a faster implementation time. So it's a lot easier to just move from one environment to another and stand it up and get it running than it is to start from scratch. And it's going to give you a much better return on your investment. So now I'd like to quickly run through some of the things you should do when you want to prepare for your modernization project. Now we do have out on our website an entire webinar series dedicated to preparing and executing a modernization project. So you will find that out there. But I'm just going to go through a quick recap right now. So if you look at the wheel on the left side here, you're going to see all the different aspects that you need to consider when preparing for your modernization project. There are a lot of moving pieces and parts. It's not just the code, it's not just the data, but it's also the security, the output management, print management, the development and test environments that go along with the application. Again, production and failover infrastructure, and what kind of tools you're going to be using for the project itself. So there's a lot of pieces here that you have to take into consideration when you are modernizing, preparing your modernization project, in addition to selecting the right people and the right products, and then, of course, choosing the approach that best suits you, the process. One of the things that we always recommend doing is taking an inventory of everything that you have. That is, all the applications. Best practice would be to find out what those applications do, who's working on those applications, who uses those applications. And then on the next slide, in the preparation, you're going to plot all of those applications out on a grid, okay, to give you a visual representation of where your applications stand today in your portfolio. So the bottom line here, on the business value, over to the left it's going to be low value to the business. On the right, it's a high value to the business. On the left side, the technical architecture, what I mean by that is not just the cost of the application, right? Whether the application costs you a lot of money, but whether it fits into your environment. Is it something that requires specialized resources or specialized staff to maintain them, etc. So if you see the box in the lower left quadrant, the eliminate box, these are the applications that may cost a lot of money. They may provide very little value. You know, there may only be a few people who are using it, and maybe they don't even really need it. Maybe they use it because they don't have any other option and that you've provided them. On the left upper quadrant, these are the applications that, while they may not present a lot of value to your company, they do fit well in your environment, and they do perform some functions that your users require. So these are applications you can tolerate. Invest in them, keep them prepared for your future needs, but these are things that you can tolerate. On the bottom right quadrant, these are the applications that we're really talking about here. These are the ones that are targets for modernization. They provide a lot of value. They could be your bread and butter applications, the ones that generate the revenue for your business, but they don't fit well in your technical environment, and they may be very costly. So when you're plotting this, make sure that you consider the end state vision of where you want to go. So when you start to pick these applications and figure which ones you want to choose to modernize, you need to consider the end state, what your strategy is. Is it all cloud? Is it hybrid cloud? The level of difficulty, right? So don't start with your most difficult application. Start with the ones that seem to be like they would be the low-hanging fruit. The approach that you're going to take, is it going to be a rewrite or is it going to be a reuse approach? And then also consider, of course, the future growth. And then once you've done that, you'll see on the next slide, you should start ranking your candidate applications for modernization. And this can be very simple. So like I mentioned, you would start with your simpler apps, such as a basic small batch application, not very complicated, easy to modernize, relatively easy to move to the cloud, and then move up to more complex applications, maybe applications that are very large and have a very complex combination of online and batch processing. And then, of course, once you pick those candidates and rate them, then just start with the one that seems to be the best starting point. So at this point, we've discussed the 7 reasons to move to the cloud and preparing your COBOL to the application move to the cloud. So I'm going to hand it over to Ed now, and Ed is going to go over the actual process to move COBOL applications to the cloud, show you some reference architectures, and talk about the cloud self-assessment. So I'll hand it over to you, Ed.
All right, thank you, Craig. Well, good afternoon, everyone. Welcome again to this webinar. I'm very happy to be with you here today. Let's continue on with our discussion. Let's take a closer look at how you can leverage, again, your core business systems and reuse those critical business systems by taking advantage of cloud technology. So before we get into the specifics of how to accomplish this, what I want us to do is just start off with a quick primer, if you will, just a reminder for folks on the phone as to the cloud environment that we'll be discussing here today. Cloud encompasses many different technologies, virtualization, platform as a service, software as a service, and many other things. What we're going to talk about today is effectively infrastructure as a service, which think of it as an environment that enables organizations, users to virtualize applications. So very much used in the same context of application virtualization on-premise, except it's in a hosted environment. And what you can see here, of course, is we're focusing on Microsoft Azure for the context of our discussion. But the same principles, same benefits apply for AWS or really whatever your cloud provider of choice technology may be. But we're going to use Azure for the purpose of our discussion here today. So when we talk about a virtual machine or a virtual environment under Azure, there's a few things we need to know, or at least be aware of. First and foremost, in terms of being able to manage that environment, there are a set of fabrics or agents, if you will, that Azure provides or the cloud provider enables so that you can control and manage the environment. They don't have anything per se to do with the applications that we'll be discussing here today, because this is more specific to the VM itself in terms of how to engage with the VM and some of the controlling behaviors around the VM. It's important to know that that exists, that there is an agent there that interfaces with that environment. And then, of course, there's a variety of different access points. So very important, once you have that virtual machine, how do I get access to it? And Microsoft, at least in the Azure example here, provides a variety of different interfaces, a variety of different tools, whether it be web tools or even just using something as simple as remote desktop to be able to gain access to the VM. So lots of different access point options available to you. Then there's the aspect of storage. So certainly there's the ability to have internal disk storage to the VM. We're pretty familiar with that. If we've set up a VM on our PC, you allocate how much storage you have for the virtual machine. But the cloud also introduces the aspect of remote storage. So you have the ability of attaching an external disk. You have the ability of accessing cloud-based storage in Azure. Think of it as sort of a shared folder. And then even something more advanced, such as database as a service, which we're seeing and hearing much more about. And in the context of Azure, we have SQL Azure services, which can be leveraged here again if you're attempting to move to a database model in the cloud. But our conversation today is going to be focused on the applications themselves, specifically COBOL. How do we take those COBOL applications that have been running in, let's say, traditional distributed environments, Windows, Unix, Linux, or even on the mainframe? How do we take those to the cloud in a way that allows us to reuse as much as possible what we have here today? Back to Craig's points earlier, how do we minimize risk? How do we minimize cost? How do we get there quickly? In terms of bringing our offering to market, but how can we leverage some of this next generation technology in an incremental way? So with that primer out of the way, let's take a closer look at the steps as to how we do this. And it's fairly straightforward, which may surprise a few on this webinar. There's actually a very straightforward process. First and foremost, what we're going to do is take a closer look at preparing the application locally on your environment. So specifically the edit, compile, debug, and test process. How do we ensure that the environment is functionally ready, it operates and delivers the capabilities we expect it to deliver, and we need to make sure that we do that in a local environment first before we consider the cloud. The second step is, of course, well, we need to configure the cloud environment. So what does that look like? So we'll leverage some of the data points that we talked about a moment ago in terms of configuring a virtual machine and what that entails, and then of course ensuring that that virtual machine is ready for the application that we've prepared in step one. The third step is then of course deploying that application to the infrastructure as a service model. So you have a couple different options here. We'll talk about different ways to do that depending on what your preference is, using some of the Azure-based tools or even just using some of the Micro Focus tools that enable you to move that application to a deployment fashion. And last but not least, of course, is QA. Certainly should be a function throughout the entire process, but final QA and testing and readiness, if you will, for production and go live. So we'll talk about some tools and what makes sense there in terms of ensuring your application is ready for users and ready for production activity. So let's take these step by step and go through them in a bit more detail. So let's talk about step one, building the COBOL application. So there are a variety of different ways to do this. What we recommend and what we certainly see more and more in the marketplace, particularly as organizations seek to move application workload to the cloud, is they want to be able to leverage modern tools to do so. Now, why is that the case? Well, there's a lot of efficiencies to gain when you start looking at modern tools from a development and delivery standpoint. Now, could you do this with a notepad or VI? Well, you could, certainly. If you have those skills, you could certainly use some of the more traditional legacy tools for developing software to move applications to the cloud. It's a bit harder. It takes longer. You're probably more prone to error. So these are some of the advantages in using some of the more modern tools. They accelerate the software delivery process. They also provide quite a few developer aids along the way, so they make our job easier. They allow us to catch syntax errors. They allow us to instantly compile the application and get instant feedback. They provide those integration points with the tools and the technologies that we want to use. So in the instance here of Visual Studio, well, that integrates very well with Azure when it comes to production and deployment and testing. So there's some great capabilities there that we want to be able to leverage, particularly as we start moving these applications into new environments. It makes the process faster and again improves quality. But effectively what we're discussing here in step one is we want to ensure that our application, whether it runs in a distributed capacity or even on the mainframe, we want to ensure that it's running successfully today. We've made the necessary edits. Perhaps we're making changes to the programs that we want to be able to move. But we want to go through the edit, compile, debug, and test process as often and as needed to ensure that we have the right result for our application. And again, the message here is to be able to leverage some of the modern tools that are readily available to help you do this. It will make it faster, and again, it will improve the quality and the result. Once you're happy with that application, running on your local machine. The next step is to be able to look at, well, what does the target environment need to look like? What does that environment in the cloud need to look like before I can move and deploy that application? So that second step requires that we have a pretty good understanding of the technology stack in step one. Am I running Windows Server? What type of transaction monitor am I using? What is the makeup of my application? What other third-party technologies need to be in play? So I need to have a pretty good listing, back to Craig's point earlier around preparation. We need to have a very good inventory of what we have of our application before we can move that application to that new environment. So once we have that understanding, we can then use some of the tools that Microsoft provides within the Azure portal, which is what you're looking at here through this screenshot. This is a web-based interface that allows you to configure your virtual machines. So very, very similar to configuring the virtual machine on your desktop or on your PC. You go through the same exercise of configuring those resources in the cloud. So you have the same type of questions, the same type of decisions come up here. The size of the virtual machine, the resources that are needed when it comes back to disk and memory and processing power, the roles that will be involved. This is a batch application. Is this an online application? So again, we need to understand the makeup of our application before we can start creating that VM. But what's nice about this tool set that Microsoft provides is that there's several different wizard-driven environments that take you step by step to configuring your virtual machine. So you can name your virtual machine, you can define the properties for it, you can provide some security provisions for it, and then of course you can define the resources, hardware, memory, processing, storage, again whether it's on disk or off disk. So lots of different decisions to make. But again, you have the resources and a very rich interface in terms of which you can design that UI. And then ultimately, when you're done, you have the ability to deploy that virtual machine, launch that virtual machine in the cloud, and then be able to access it as any other resource. So if you recall back to our primer on IaaS, when we talked about infrastructure as a service, now we are talking about how do we gain access to the virtual machine. Once it's launched, how do we gain access to it through a different web-based interface, through remote desktop, which is often very popular, so that you can start deploying that application that we talked about in step one into the cloud. So if we follow step two properly, we should have a virtual machine fully configured, ready to go, and accessible to us. Then we can follow to step three, which is deploying that application into the environment. So some things you need to have right out of the gate here installed on your virtual machine, first and foremost, because our context is COBOL Applications, is you need to have the Micro Focus COBOL runtime or server environment deployed on your machine. There are lots of different variants and flavors in terms of how you can deploy your application, whether you want to have it deployed as a native COBOL, or you want to have it deployed as COBOL under .NET, or maybe as COBOL as Java, COBOL deployed as Java bytecode. There's lots of different variations, but ultimately you need the runtime environment because it provides that efficiency and it also provides that transparency between some of the native COBOL behavior and that what you're going to see under Azure or certainly under a Windows environment. So what do we do here? Well, there's a couple different options. We can take the path of using some of the native Microsoft tools, things such as the Azure Resource Portal. Think of that as very similar to a file explorer. It allows you to be able to quickly upload files into your virtual machine environment. So for example, if you've compiled your application on your local PC, you've compiled it and deployed it to your release folder, you can quickly map your application, all of the binaries, all of the third-party DLLs, etc., quickly using that resource explorer and upload those files to the Azure portal. And at that point, again, you'll have your application deployed in the cloud. That's one option, is to use that type of copy and paste or upload facility. Another, which is fairly popular, particularly in a dev test scenario, is to be able to install the development tools on that same virtual machine. And there's certainly nothing wrong with doing that. You can install the components directly on the virtual machine again, compile it, and deploy the application from the IDE directly to the VM. That's an alternative as well. Some like to do that because then, of course, they can set some debugging flags and test the application as it goes through pre-production. So there's a variety of different options here that you can choose, but the important point to remember is, of course, you need the Micro Focus runtime on that virtual machine to enable you to run the application once deployed. The fourth and final step is, well, something we've been talking about frequently up to this point, which is testing. We want to ensure that testing is a component throughout the entire process, of course, but before we deploy the application in a production capacity, traditional production capacity, make it accessible to users, or in the context of a batch application, before we start scheduling those batch jobs, we want to ensure that the application's running as expectedly. We want to be able to perhaps see this application running at scale. So it's more than just unit testing, it's regression, systems, performance testing. And there's a variety of different tools, again, that are integrated with Visual Studio, integrated with Azure, and integrated within the Micro Focus tool stack to help you test your applications quickly. So again, back to our conversation around development tools. Yes, there are other ways of doing this. You can certainly use manual tools, manual ways of testing your applications, but there are more efficient ways to do this, more integrated ways, and there are benefits to be gained by using some of these tools. You can iterate faster, you can schedule these tests to take place perhaps outside of workday hours. You can scale the testing to meet the anticipated demand. So, back to some comments we talked about earlier in terms of perhaps, seeing peak usage or peak demand in your business. You want to be able to replicate that. Well, you can simulate that using these tools to be able to get a better understanding, is my application going to scale under this virtual environment, or does it need more resource, more processing power, more memory, etc. So a great set of tools are available to help you do this, and again, they're integrated with either Visual Studio or Eclipse, and of course the Micro Focus tool stack as well. So that's the process in terms of moving an application, particularly a batch application, to the cloud. What I want to share with you now are a few example reference architectures, because these are the questions that come up quite frequently as well. How do we map a source environment to a target environment when we talk about the cloud? So let's take a closer look at a few examples, and we'll start with a distributed example, and then we'll go to an example that's more focused on the mainframe. So for organizations that are running COBOL applications on, let's say, Windows, Unix, Linux, or even Linux environments, on an IFL, on the mainframe, or on Power Platforms. This would apply to you, this type of architecture. So typically you have, generally speaking, you have some languages that your application your COBOL environment consists of. It may not be COBOL itself. It may include VB or C# or others. You have some transaction management facilities that are taking place. You have some other utilities around scheduling, around management and security. You'll probably have some batch scripts as well to handle some of your batch jobs, and of course you'll have a data infrastructure. Traditionally, they're usually COBOL data files, but not necessarily. You may have a relational database management system as part of the picture as well, but this is the typical stack you tend to see. And yours may vary or may look very much similar to this. When you start mapping this to Azure, what you tend to see is, well, there are some decisions you need to make in terms of what that equivalent to technology would be under Azure. And when it comes to the COBOL application, what Micro Focus offers, and certainly some of the expertise that Astadia can help deliver, is that we can enable you to reuse as much of your COBOL application as possible. So we can limit the amount of code change that it takes to move from one environment to the next. But there are going to be some other conversations, other changes you're going to need to make, to Greg's point earlier, around the other infrastructure pieces. So perhaps the data model. Maybe the data model is going to move to something more aligned to SQL Azure, and you're going to move to a database as a service model. You don't have to, but that's an option. Some clients have stayed with just flat files and stayed with COBOL data files on Azure. That's a perfectly acceptable architecture, and that's something that you can continue to use as well. You need to make some decisions around scripts. You need to make some decisions around security and some of the infrastructure components. You'll need to make some decisions around perhaps some other legacy languages that you may have on your distributed platform. But this is typically the mapping that you'll see when you start to move your workload to a cloud environment, and you mature that environment over time. Our conversation today is about lowering that risk and helping you move as much as possible without change. But typically what we see is, as clients develop and move more and more workloads to the cloud, there's an appetite to modernize and an appetite to deliver more capability. And that's going to require adoption of newer technologies, and some of the technologies you see here on the right. So this is the distributed model, or distributed example. Let's take a closer look at what this would mean if you were running your applications on the mainframe. Now instantly, I think what you can see here is that, well, there's a few more moving pieces, right? Particularly for those of us that are familiar with IBM mainframe architecture, we can see that it's a little bit more than COBOL. COBOL's an important piece, but we have some PL1, we have assembler, we have things like CICS or maybe IMS, we have JES and JCL, lots of different components here, of course DB2, etc. And this is typically running on ZOS or a ZVSE environment. So moving that stack to Azure is a bit more involved than a distributed environment because, as I mentioned, there's a lot more infrastructure, a lot more subsystems that come into play. But again, back to our conversation earlier about minimizing risk and making this as easy as possible, particularly for step one. So Micro Focus enables you to do that using a tool set called Enterprise Server. And this is a capability that our friends at Astadia have expertise and consultancy around, is understanding this platform and being able to help clients move applications that are running on the mainframe to Azure using that technology. So think of Enterprise Server as effectively an emulation environment for mainframe applications. We enable you to run your COBOL applications, your PL1 applications, your CICS applications, your JES, your DB2 under a single environment, or even a single container. Now you can get pretty creative in terms of the architecture under Azure in terms of your virtual machine as well. You can have different pieces running under different VMs. You can have different models in terms of failover and recovery and load balancing. But we tried to make this simple in terms of putting this in all one place here for the purpose of the graphic. But you can get very creative and customize this as you wish. But again, there are going to be some decisions that you'll need to make, particularly when we talk about the data model. Do you want to stay with a relational database? Are you going to stay with flat files? What makes the most sense for the business? From a security perspective, particularly when we talk about Azure as a target cloud environment, you're probably going to gravitate more towards Active Directory or to an LDAP, security repository. So how does that map from something like a RACF or ACF2 to an LDAP environment? And there's going to be other, other conversations you're going to have as well around tooling and, of course, enabling your existing development and deployment teams to support those applications. But an important piece to know is that you have flexibility, you have portability. If you compare the operating platforms on the right-hand side, now you notice you have some choices. You have some choices around where I want to deploy this workload. Yes, it's deployed under Azure in an infrastructure as a service model now, but maybe it's running on Red Hat, maybe it's running on SUSE, maybe it's running on Windows, maybe it's all three, depending on what your needs are. But again, that's the flexibility you have when you start looking at Azure for mainframe workloads.
And I would just add there that in this particular slide, we're looking at IBM mainframe environment. The same is true for a Unisys environment as well. So if you're watching this and you're a Unisys mainframe person, don't think that you're left out. This is absolutely possible for Unisys mainframes as well.
That's a good point, Craig, absolutely. And we could go on and on. We could add probably another half a dozen reference architectures for Unisys and some of the other environments that we see and experience. It's very possible. And, again, the same principles apply. Some of the technology is different, of course, but the same principles apply in being able to shift that workload, those applications with as little change as possible over into the IS environment.
Yep, that's right.
All right, well, very good. Well, let's just do a quick review here in terms of what we've seen and what we've discussed. So hopefully I've given you a sense that, IaaS equates to really just deploying your application workload, deploying a virtual machine in the cloud. That's really what we're talking about, and think of it as virtualization, but it's step one in moving your application to the cloud. There are a variety of different tools available. The tools we're talking about here from Micro Focus, Visual COBOL for Visual Studio or Eclipse help you do this in a very efficient way. Again, they're highly integrated with the Microsoft or certainly the AWS cloud environments to help you build, test, and deploy those applications, whether it be locally or to the cloud. Building that virtual machine is fairly straightforward, hopefully from what you've seen. Microsoft provides a variety of different tools and wizards to help you do this. There are plenty of different tech notes on the Azure website to help you get started quickly. And the process of deploying the application, particularly batch applications, to the cloud is straightforward as well. There's lots of tools from Microsoft and Amazon to help you do that in terms of moving those compiled objects up into the cloud. or you can use the Micro Focus tools to connect directly to the virtual machine and deploy from within the IDE. So a very straightforward process here of being able to take applications quickly to the cloud. So what we like to do now is just start with a quick self-assessment, give you a sense for, well, based on what you've seen and heard from Craig and I so far, is cloud the right platform for you? How do you know if moving your application workload is appropriate, is going to give you the right ROI, is going to help align to some of your goals that you may have for your business? So what we have here to share with you are just really some starter questions. And let's just look at three of them together here. Do you need to scale your applications in response to increasing demand? To a point that we discussed earlier, is demand changing? Is it cyclical? Do you experience peaks? Do you not have enough resource to scale? If the answer is yes, then well, cloud may be something you want to consider because it can help you solve that problem. Another question, of course, is around infrastructure costs. We know infrastructure costs are increasing. There's pressure on IT to find new and creative ways to respond to those cost challenges, but also find new money for new innovation. So again, you have to find that right balance between controlling cost and investing in the future. If your answer is yes to that question, then cloud may be the answer for you because it can help you reduce your infrastructure costs, but then also put you in a position to innovate. And a third, as you can see here, is around .NET, Java, and the cloud. When we talk to our clients, we hear over and over again that .NET, Java, they're platforms for the future. They're platforms right alongside the cloud that organizations want to adopt. They want to achieve some of the benefits that they deliver, and it's part of their future IT strategy. So if that's your goal, if that's part of your future goal, then this is certainly a next step that you want to take because it can help align into fulfilling that strategy over time. This is an incremental path, so we're not talking about moving all of your workloads. You can do this in a programmatic fashion. You can do this application by application, and you can apply the principles where it makes sense for your business. So with that, what I'd like to do now is turn things back over to my colleague Craig, to wrap up. I hope that's been informative for you, and thank you very much.
Yeah, thanks. Just a quick recap. So we discussed 7 reasons why you should move your COBOL applications to cloud in 2017, and we discussed some of the options for that. There's really 3 options, and that is rewrite, replace with a package, or reuse. And of course, we advocate reusing as much as possible, wherever possible. And then Ed went through the steps to prepare, or sorry, I went through the steps to prepare for your modernization project, and then Ed talked about the steps of moving into the cloud and the process of the basic process of moving your COBOL application to a cloud environment, and then a reference architecture. And just a reminder that we have been very Azure-centric in our presentation today, but everything that you've seen applies to any cloud vendor, not just Azure. And then Ed went through the cloud self-assessment and the top 3 questions to ask yourself there. So you're probably wondering, okay, what do I do? What's the next step? How do I get started? Well, a great way to get started is to contact us for a value profile assessment, and that's really to get you started and get your first steps into the cloud. It is a complimentary 1-day session with Micro Focus and Astadia experts to discuss with your application stakeholders and those who have vested interest in your application running in the cloud or running as efficiently as possible. Some questions and answers sessions with them and all the stakeholders, some technical reviews, preferably having a peek at your source code to give you an idea of the effort that's going to be involved, and talk about how it'll fit with your strategy, and then we can provide some recommendations within a relatively short period of time. So this is a great way to get started, and we hope to hear from you. And with that, I'm going to hand it over to Greg for the Q&A.
Excellent, guys. Ed, Craig, thank you very much for that presentation. We've got 4 questions in the queue, Craig, and I think the first one is really kind of directed at you. And this one says, what are the differences between moving mainframe COBOL apps to the cloud versus distributed COBOL apps?
Right. So distributed COBOL apps are applications that are already running on a distributed platform. So moving that to the cloud is really about as easy as you can get, because you're essentially moving from one architecture to a very similar architecture in the cloud, and that architecture being an x86 Intel type platform. So that is a relatively straightforward proposition. Mainframe is a little different, and there are a couple reasons. One is, of course, you've got a lot of different pieces and supporting software pieces on the mainframe that you need to replace or somehow address when you move to a distributed or cloud environment. The other is, everybody knows the mainframe is an EBCDIC environment, and the distributed environment is ASCII. Now, that's not a huge problem, because any FTP process will do an EBCDIC to ASCII conversion, but there are some differences in the processing. Not a lot, but around sorting. So sorting in EBCDIC and sorting in ASCII can be very different. So you have to account for those types of situations and address those when you move to a distributed or a cloud environment. Those are the primary differences.
Okay, Craig, thank you. Ed, I think the next one is yours. The question is that you spoke very directly about batch programs. Is the process the same for online programs? And if not, what are the unique challenges that we might face?
Sure, absolutely. Good question. Yes, we did focus our content here today around batch programs, and of course, in moving batch programs to an IaaS environment. As Craig mentioned, I mean, that is fairly straightforward. I mean, that's something that you can achieve today with little to no change within your applications, and achieve the benefits that cloud offers in terms of elasticity, cost, and of course, innovation, as we discussed. The same is possible for online applications. There are some intricacies, though, and differences that require some additional planning. Typically what we find when organizations want to move applications that have an online component is that there's typically a discussion at the same time around modernizing or improving that user experience. Very seldomly do we hear that an organization wants to take their user interface as is and deploy it to the cloud. There's usually some customization, usually some change that takes place or is planned right alongside with that move. Now, that's not to say that you can't do that. You can certainly take your green screen application to the cloud. If it's running on the mainframe, again, some of the emulation technology under enterprise server supports that model. So that's certainly something you could do under IaaS. But again, like I said, what we tend to see more often is there's usually a conversation around improving the user experience when you're in the cloud. There's the conversation around mobile users and mobile data access. So again, it usually sparks a conversation around revamping the UI, and that of course brings in some additional work and additional pieces you need to plan for.
Mm-hmm.
Okay, all right. Craig, I think this may be yours too. The question is simply, how difficult is it to move data?
Yeah, it's funny, when we were going through some of the reference architecture stuff, this webinar is about applications. We did not really talk about data. Our other webinar series discusses data in more detail. But so with distributed data, it's just like a distributed application move. It's very easy because, again, you're going from a similar platform. You're moving between similar platforms. So that's a relatively easy move. That is essentially setting up an equivalent database in the cloud environment, pumping the data through, and then doing some validation work to make sure that the data maintains its integrity. Fairly easy process. Again, for the mainframe side, you are going to have some additional work. Some of that is around the ASCII, EBCDIC to ASCII conversion. Again, that is nothing huge. Any FTP process will do that conversion for you. However, there will be some situations where, especially where comp fields on the mainframe are concerned, you will have to do some manipulation around comp data fields. So that's going to require some analysis and some extra work, but it is by no means inachievable. We have, in fact, a tool that we have used that we developed internally that will take mainframe data and move it down to the distributed side and do all of the changes that you need to do in the process. So, and it also does some validation. So that process remains the same. There is one other aspect. A lot of mainframe packages have distributed equivalents, right? So maybe you have, for example, the Current package that runs on the mainframe, and it does have a distributed equivalent. However, the data is very different and requires some special manipulation even beyond just the regular elasticity to ASCII conversion and the handling of comp fields. There are certain types of keys that are very, very unique to the Current environment on the mainframe that require some sophisticated changes in order to work in the distributed environment. So there may be certain things that you have on your mainframe that you want to move into the cloud that need some special treatment. Again, none of it is you can overcome all of these obstacles. It's just a matter of identifying them and addressing them.
Okay, thanks, Craig. We have another question from the audience here, and I'll let you guys decide which one wants to take this one. It said, what would be your recommendation to go from a mainframe COBOL to the cloud if we are currently working with vSAM files and no database? How could we reduce the migration impact? I guess the migration impact in performance, and what could be the equivalent to a vSAM file in a cloud environment?
Okay, well, moving vSAM flat files is relatively easy. As I mentioned, you have the, I'm assuming we're talking about a mainframe, existing mainframe environment, something that hasn't been migrated before. So you're going to have the elasticity to ASCII conversion. You're going to have to deal with any comp fields, certain types of comp fields, and you're going to have to also take a look at the application and the sorting sequences to see if there are any impacts there. Beyond that, it's really up to you, the customer, and what you want to achieve. So, as Ed mentioned earlier today, running vSAM in a cloud environment, it works great. But you have to consider, what do you want to do with that data, okay? So if you put that into a SQL environment or a relational environment of some kind, then that opens up that data to all kinds of possibilities, sharing with other applications. It's a lot easier to integrate with other applications. That's not to say that you can't do that with vSAM as vSAM, but it just makes it a lot easier and more effective to go to a relational database environment. And it really, again, just depends on the purpose of that data. If that data is used by that one application, always will, never will be used by anything else, and it works the way it does today, works well, then, hey, just leave it, right? But if you want to share that data quickly and easily, it's best to move it to a relational environment. Ed, I don't know if you want to add anything to that.
Oh, that's great, Craig. I mean, yeah, I mean, absolutely. I would only add maybe that, you know, take a look at your application inventory. You know, you mentioned, of course, the vSAM data model and in the context of the mainframe. You know, how many applications is one of the first questions that comes to my mind. You know, is this a technology, a portfolio that you can look at and start to compartmentalize? Because many of our clients, you know, particularly those that are starting and considering this type of move, will want to do it in an incremental fashion. So they start looking at pieces of an application, perhaps looking at it at a program-by-program level, you know, and there's some tools that we can help, leverage to get a better visibility into what the, what's a logical breakpoint for an application, you know, where are perhaps some applications that, are sensible to move to the cloud based on the architecture, Where is perhaps some dead code that you could eliminate and perhaps, reduce the code base that needs to be moved. So there's some intelligence tools you can use at the forefront to get an understanding of, well, what can we move? What is the lowest risk? And then to your point around performance, I mean, most certainly, I mean, if your goal is to limit risk and move to the cloud without change, then, some of the emulation tools we've talked about under Enterprise Server will let you do that today. But, to Craig's comment, a few moments ago, it's absolutely right. And once you're there, I think the conversation becomes, well, how do you modernize and make this better? How do you improve the experience? How do you deliver new services to your users? And that's where you start to look at, well, okay, vSAM is an appropriate model. We get some good performance gains, but is it going to give me what I need for my end users? And how does this align to my future strategy? And you might find yourself looking more towards a relational database over time.
Yeah.
Oh.
Yep.
Okay, great. Both of you mentioned performance in your answers, and the next question from the audience actually seems to focus on performance. The question is, what about performance considerations between the mainframe and distributed, whether that be cloud or otherwise? Is there a way to achieve some sort of parity so that we can expect similar runtimes in a cloud environment as we do in an on-premise mainframe environment?
Absolutely. Well, why don't I start? I think you probably have some thoughts here too, Craig. I think absolutely. So what do you do? This comes into conversation around best practices and tuning for applications, and every application environment is different. So I don't think there's a de facto answer here to say that you always do this and you'll be in good shape. We have to understand the characteristics of the application. You mentioned mainframe and distributed. In some constructs, we see that applications are built across platform. It's not just mainframe. There are components that are integrating with on-premise distributed pieces as well. So how do you move both of those to the cloud? There are some conversations you're going to have there pretty quickly around, well, what makes the most sense, from a target architecture standpoint. Is your goal to maybe perhaps simplify the stack, simplify the technology stack, make it easier on maintenance? But in terms of performance, in terms of data, data files themselves, COBOL data files, vSAM files, I mean, they're traditionally known for being high performant. You can continue to run those in the cloud, without code change. The applications themselves, COBOL, traditionally, well known for, processing speeds, performance, precision. You can continue to run your traditional COBOL without change. I think you're going to have a bigger conversation around some of the third-party components that are part of your application. The other languages that interface with it, and how do we replicate that capability in the cloud? Can we take it as is, or do we need to look at a different model?
And
what are your thoughts, Craig?
In the performance aspect, we've had customers in the past, actually some pretty skeptical customers, who once they move into production on the distributed platform from a mainframe source, find that their batch runtime and their performance improves significantly. There are a number of reasons, possible reasons for that. One is, the power of the PC chips, today's chips. But there will be some cases where it takes some time to tune them. You may find that you may have to throw more processors at the environment to get the throughput that you need to perform as you want, which is one of the great things about virtualization, is you can just say, oh, well, let's throw a couple more cores at it and see what happens, right? You may have to make some changes to your I/O. Sometimes the performance issue isn't the processing power, but it is a bandwidth issue, a networking issue that has to do with I/O. So you may have to do some tuning around that. But we have yet to come across any application that we've migrated that we couldn't get to work as well or better than the source application.
That's a good point, Craig. One of the things you do need to look at is I/O, because sometimes it's proximity of the data. Just, if there's a long distance between the application and the database, I mean, that's going to add lag time. So there's different, as you say, tuning techniques you can look at, for, in terms of configuring the software, the proximity of the VMs, to each other, or just the makeup of the software stack itself within the VM, to sort of, gain some performance advantages. But this really goes to the sort of those next steps that Craig talked about towards the end, which is that assessment. Those are some of the things that we discuss at that assessment, is sort of the current model today. What are your SLAs and performance, sort of outcomes today, and what do they need to be as you look to move to a different environment?
Mm-hmm. All right, excellent discussion. We have two more questions in the queue right now, gentlemen. So the next one is, I did not see assembler as being addressed coming from the mainframe. How is this converted?
Okay, so yeah, assembler is always rewritten. We have come across some emulation products for assembler in the past, but none that we felt were really good enough for production. So assembler is always analyzed and rewritten. Now, it can be rewritten in any language you want. It depends on your strategy. So if you want to keep it similar to the rest of the application, you can rewrite it in COBOL, and we do that all the time. And it works well. However, you'll have some customers who say, you know what, I'm going to a distributed environment, I'm going to, let's just say, Linux, and I want to use Java, so I want to rewrite in Java. Okay, then you rewrite in Java. So assembler is one of the components that you need to look at very carefully and handle through a rewrite. The same is true for Algol on the Unisys side. Did you have any comments on that?
No, that you're spot on there, Craig. I think there's always going to be, some other languages that you can't map one for one in terms of moving from distributed to the cloud. And in those instances, yeah, we have some choices. Looking at COBOL as an alternative, or some clients choose to move to Java or .NET. But there will be some of those situations where we'll have to look at new targets for some of the languages you're using today.
Excellent. Okay, we got one more question in the queue. There may be a few more coming in. This is more of a statement, but it goes, so I can move my NetExpress and dialog codes along with my COBOL file, the DAT and IDX file, to the cloud without changes. Is that possible?
All right, I'll take that one, Greg. Absolutely, yes. You have the ability, absolutely. If you're using Micro Focus NetExpress today or Server Express technology, and you have some dialogue with as a user interface using COBOL data files, you absolutely can take your application to the cloud. I think we want to have a conversation with you at that assessment around the future of your user interface. Are you going to stay with dialogue systems? But certainly, if you look at infrastructure as a service as step one in moving to the cloud, you certainly have the ability to virtualize that application, deploy it in a hosted environment under IaaS or perhaps AWS if that's your preference. But I think most certainly you'll want to have a conversation about the future strategy of your UI, because I think what you'll find as you look to step 2 and step 3, you'll probably want to change and evolve that, maybe move it to a different Microsoft technology around Windows Forms, WCF, or maybe even a web-based app.
Okay. Craig, anything to add to that?
No.
Okay, perfect.
Got it right on.
Okay, well then the last question has actually been asked a couple of times, and I guess really I'll throw this out to both of you. Are there training materials available where people can go to learn a little bit more about what we've talked about today?
Okay, so I'll just start out by saying, we mentioned we do have a 3 or 4 part series, webinar series that discusses modernization in general and how to prepare for a modernization project. I think that's a good place to start. And then if you're talking about specific Micro Focus technology, I will hand that over to Ed because I know that they have a huge wealth of resources there.
Oh, you're right there, Craig. Absolutely. There's lots of things that folks can take a look at. I think probably the first place we would send you to is the URL you shared towards the end of the webinar, which is microfocus.com/cloud, and that gives you some insight into some of the things we've talked about here today. There's also a great how-to video that's going up there in the next week to step you through this process again if you want to try it for yourself. But we also have plenty of materials within the product itself, whether your focus is around distributed COBOL, NetExpress, or ServerExpress type applications, or your focus is on Unisys mainframe or IBM mainframe, our different product stacks, Visual COBOL, and Enterprise Developer, that documentation is freely accessible online at microfocus.com.
All right, very good. Well, we have no further questions. So Ed and Craig, I just want to thank you very much for your time and expertise, and thank everybody in the audience for joining us today. It's been a good afternoon, and we look forward to seeing you again soon in the future. Thanks, everybody.